Today we'll discuss current divider rule and voltage divider rule. Where we will apply the voltage divider rule and where we will apply current divider rule. Before that, we will see series and parallel. Suppose if resistances are in series like this. If three resistances are in series, what is the equivalent resistance?
R equal to R1 plus
R
R2
equal
plus
to
R2.
R1
R1 plus R2 plus R3.
R1 plus R2 plus R3. Let us assume current I is flowing in series circuit. Let us assume current I is flowing in the series circuit. What is the current in resistance R1?
I.
I.
Resistance R2?
I.
Okay, similarly R3 also I.
I.
I is the current that is flowing in series. In series, current will be same. Whatever may be the number of resistances we are connecting in series, same current will flow in R1, R2 and R3. In series, current will be same. Write down note. In series, current will be same. In series, current will be same in all the elements. In series, current will be same in all the elements. Here element means resistance, okay, in all the elements, but voltages are different. Let us take an example. I am taking this is 1 ohm, 2 ohm, 3 ohm. All the resistances are different values. Now here I am taking the voltage 10 volts. I am taking the voltage 10 volts. Okay. Now draw the circuit. Now I will determine the current. How current will flow in the circuit?
Negative
How
to
current flows?
positive to negative.
Negative to positive.
Negative to
Always
positive.
current flows from negative to positive, from voltage source. I have already told you, if this is the voltage source, current flows from negative to positive terminal. Okay. Now current is flowing from negative to positive terminal. Let us assume, not assume, current always flows from negative to positive, like this. Current I is flowing from negative to positive. Current is flowing like this. That means current direction is this one. This is your current direction. I. Now here, in the direction of current, we can take plus and minus only for resistors, but not for the voltage source. In the direction of current, I will take plus and minus. Now, minus to plus, plus 10. I is flowing from minus to plus. Plus to minus,
Minus.
minus 1 into I.
I.
Minus. Algebraic sum of voltage drops in a loop is equal to 0. 5, 6, 7 is equal to 10. I is equal to 10 by 6. That is equal to 1.66 ampere. This is the current. Now 1.66 ampere is the current flowing in 1 ohm, 2 ohms, 3 ohms. Same current is flowing in all the resistances. Now come to the voltages. Now I want to determine the voltage across 1 ohm. Let us take this is V1, Voltage across 2 ohms is V2. Voltage across 3 ohms is V3. Now I want to determine the voltage across 1 ohm, because in series current is same but voltages are different. Now see, V1 is equal to 1 into I. Voltage is equal to resistance multiplied by current. V2 is equal to 2 into I. Resistance multiplied by current. V3 is equal to 3. Current is same in all the resistances, but voltages are different. That is 1 into I is 1.66 volts. This will be 2 into 1.66. This will be 3 into 1.66 volts. Now what is V2? Tell me the value.
3.32.
3.32.
3.32 volts. Now what is V3?
4.98.
4.98 volts.
4.98.
Volts.
Now add V1, V2 and V3. V is equal to V1 plus V2 plus V3. What is the value?
9.96.
How much?
9.96, sir.
9.96. That means you will get 10. If you take exact all the decimal values, you will get 10. Because here 10 volts is applied across all these three. If you add these three voltages, V1 plus V2 plus V3, you have to get 10 volts. If you add these three, some decimal, exact decimal values, if you take, we will get 10 volts. We have to get 10 volts. Okay. So here current is same, but voltages are divided. Voltage is divided as 1.66, 3.32, 4.98. Like this, voltage is divided. That means in series, we will apply voltage divide. Write down side heading voltage divide rule. Side heading voltage divide rule. Voltage divide rule. Side heading voltage divide rule. In series, voltage will be divided. That's why you'll apply voltage divider in series. Current is same in series. Only voltages are different. That's why in series we'll apply voltage divide rule. Now, what is voltage divide rule formula? See here. Now I want to determine V1. Here V is the total voltage. V is the total voltage. If you want V1, V1 is equal to total voltage into
Sir, your video not coming.
write down V1 is equal to total voltage V. Write down V1 is equal to total voltage V into total voltage V into same branch resistance by total resistance of series connection. V1 is equal to total voltage into same branch resistance by total resistance of series connection. Total resistance of series connection. Okay, this is the formula for determining V1 directly without following this entire procedure. Without following this entire procedure, directly if you want V1, we'll write here total voltage is 10. Here, where is V1? V1 is at 1 ohm. Same branch resistance. V1 is at 1 ohm. That means 1 by Total resistance of series connection. What are connected in series? 3 resistors are connected in series. 1 plus 2 plus 3. Same branch. V1 is across 1 ohm. That's why I am taking 1 there in the numerator. Same branch resistance means wherever V1 is there, we will take that resistance. Similarly, V2 is equal to total voltage into, where is V2? Where is V2? Across 2 ohms. Across 2 ohms. 2 by 1 plus 2
1
plus
plus 2 plus
total voltage into V3 is across 3. 1 plus 2 plus 3. We'll get same answers. What you will get? 1.66, 3.32, 4.9. If you calculate this, you'll get same answer. Total voltage into same branch resistance by total resistance of series connection. This is the voltage divider rule formula. In series, we will apply voltage divider rule. Across all resistors. Okay, remember this formula. Total voltage into same branch resistance. It is applicable only to series connection. Not done. Note, voltage divider rule is applied in series connection. Series connected resistors. Voltage divider rule is applied in series connection. Once again, I am explaining. See here. In series, the current is same. I is flowing in R1, R2, and R2. Same current will flow in series connected resistors. Let us take an R equivalent is equal to R1 plus R2 plus R3 in series. Let us take an example. 1 ohm, R2 is 2 ohms, R3 is 3 ohms. Here, 10 volts total voltage. I am taking 10 volts. I am applying. This is the battery voltage. 10 volts I am applying across R1, R2, and R3. Now, current always flows from negative to positive. Current is flowing like this. Now, apply KVL. Apply KVL here. If you apply KVL, you will get current I. You know how to apply KVL. Okay. Current I, we are getting this. Then voltage V1 is equal to I into 1. V2 is equal to I into 2. V3 is equal to I into 3. Okay. This is the general procedure I have to. Without applying this procedure, directly you can determine V1, V2, V3 by using voltage divider. Voltage divider is V1 is equal to total voltage. Total voltage is 10 into same branch resistance. V1 is across 1. That's why I have taken 1. V2 is across 2 ohms. V2 is across 2 ohms. V3 is across 3 ohms. We'll get same answer. 1.66, 3.32, 4.98. If you add V1, V2 and V3, you have to get 10 volts. V1 plus V2 plus V3 is equal to 10 volts total voltage. That's all about the voltage divider rule in series. In parallel, we will apply current divider. In parallel, we will apply current divider. Why means in parallel voltage is same, but current is different. In series, current is same, but voltage is. Write down note. In series, current is same, but voltage is different. In series, current is same, but voltage is different. In series, current is same, but voltage is different. Next note, second point, note 2. In parallel, current is different, but voltage is same. In parallel, current is different, but voltage is same. In parallel, current is different, but voltage is same. Now we'll see this. Let us take this is R1, this is R2. Equivalent resistances. If you simplify this, we'll get. Already I have explained this one. If two resistances are in parallel, your equivalent resistance is R1 R2 by R1 plus R2. Note down this.
Completed, sir.
Okay. Now let us take an example. I am taking 10 ampere total current. I am taking the total current 10 ampere. Now let us take R1 is equal to 2 ohms, R2 is equal to 4 ohms. Draw this diagram, circuit diagram. How many node points are there? How many nodes are there?
One.
One, sir.
So this current is coming towards this node. This I is equal to 10 ampere is coming towards this node. This current is dividing at this node point into these two branches. Let us take this is I1, this is I2. This is the incoming current, these two are leaving currents. This total current is coming towards the node point. At node, this current is dividing in these two branches as I1 and I2. Now apply KCL. Incoming current is equal to outgoing currents. I is equal to I1 plus I2. I is the incoming current. I1 and I2 are leaving currents. Sum of incoming currents is equal to sum of leaving currents according to KCL. According to KCL, incoming current is equal to outgoing currents. If you are having node, then only your current will divide. Please remember, note, write on note point. Current divides at the node point. Right? Current divides at the node point. Current divides at the node point. So if there is no node, there is no parallel circuit. Remember this point. If you are having node, then only your current will divide. If there is no node, then all are in series. If there is node point, then only your current will divide. Now see here. Now I will determine the currents. I1 and I2. I1 is the current flowing in R1. I2 is the current flowing in R2. I1 is equal to, write down, total current into opposite branch resistance by total resistance of parallel branches. Right up? I1 is equal to total current into total current I into opposite branch resistance by total resistance of parallel branches. Opposite branch resistance by total resistance of parallel branches. Now I will determine I1 and I2. See here, your total current is
10,
10
sir.
ampere.
10 into 4.
For I1, what is the opposite branch?
4.
4.
4 ohms. Okay. Opposite branch. I1 opposite you have to see 4. Divide by total resistance of
2 plus 4.
parallel branches.
2 plus 4.
4. Similarly, I2 is equal to total current. I2 is flowing in R2. For this I2, what is the opposite branch?
2.
2.
2.
2.
2 by total resistance of parallel branches. See,
2
parallel,
plus
I have
4.
told parallel branches. Now determine I1 and I2.
6.66.
How much is this?
6.66, sir.
6.666.
3.33.
3.33.
How much?
3.33.
3.33.
3.33, sir.
3.33.
Now add I1 and I2.
Approximately 10.
You'll get 10 amperes.
9.99.
Yes, sir.
Okay, 9.9 approximately 10 ohms. 10 amperes.
Parallel connection, how you added that both the resistance, sir?
How we?
Added that both the resistance, it's parallel connection, no, sir? How can you add directly?
See the formula.
Total.
Total
Yeah.
resistance of parallel branches.
Parallel.
Total resistance of parallel branches. This resistance plus this resistance. I am telling that total
Only
resistance
we
of
should
parallel.
add that. Okay.
Total sum of resistances of parallel. If you are having doubt, you can write here. Total sum of resistances of parallel branches. Total sum of resistances of parallel branches. Okay. Is it clear now?
Sir, I have a doubt.
Tell me.
Sir, if we have 3 resistances, then how will we decide the opposite branch?
Okay. I will
R1,
tell
R2,
you.
R3.
Yes, sir.
We'll do the next problem.
Okay, sir.
If you have completed, we'll go to the next problem. Determine the current in all the resistors. Determine the current in all the resistors using current divider. Determine the current in all the resistors using current divider. Okay, see here. Now, how many nodes are there?
1.
Only one node is there. Now, this is the total current I. This total current is coming towards this node. Here it is coming. 8 ampere is coming here. This 8 ampere is dividing in these 3 branches. Let us take this is I1, this is I2, this will be I3. It is dividing, total current I is equal to, incoming current is equal to outgoing currents. Incoming current is I2. Outgoing currents are I1, I2 and I3. Now we have to determine I1, I2 and I3. First I will determine I1. So what I am doing is, see here. This I1 as it is I am keeping. I have to determine I1. So I am not disturbing this branch. This branch is kept as it is. What these two are in parallel or series?
Parallel.
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 Now determine the equivalent resistance of these two. R equivalent
6
is
by
equal
5.
to R1 R2 by R1 plus R2.
2 plus
1.2.
R equivalent is equal to 2 into 3 by 2 plus 3. That is
1.2, sir.
by
1.2.
1.2 ampere. Sorry, ohms. It is equivalent resistance. 1.2 ohms. Now here I want I1. I1 is equal to total current. Total current is 8. Your formula. Total current into what is the opposite branch for I1?
1.2, sir.
1.2.
1.2 divided by
1 plus 1
Plus
point
1.2.
1
1
and
plus
1.2
1.2.
are parallel.
2.2, sir.
2.2.
Okay. These two are parallel. 1 and 1.2 are parallel. You should not disturb I1 branch because we are determining the current in 1 ohms. What is the value?
0.5.
0.5.
10.8, sir. 10.8.
How much?
0.54, sir.
0.54
4.
ampere.
5,
This is now let us go for I2. Now here I am drawing the correct circuit. Okay.
4.32, sir.
4.32, sir.
4.32.
Okay. Now see here, I am taking 8 ampere and this I2 I am not disturbing. This I2 branch I am not disturbing. This I2 branch I am not disturbing. This 1 and 3 are in parallel. How much?
0.75.
R equivalent is 0.75 volts. Therefore, I2 is equal to total current into. So for this 2 ohm opposite branches 0.75 divided by
2.
divided by
0.18.
2.181.
2.181. Okay, this is your current I2 in 2 ohms. See here, I2 is flowing in 2 ohms. We should not disturb this branch because we have to determine the current in this. These two are parallel, convert into single resistance. Now I will take current in 3 ohms, I3. I3 is equal to total current into, what is the opposite branch for 3 ohms?
0.66.
How much?
0.66, sir.
0.66.
0.66. Three and 0.66 are parallel.
1.44.
1.44.
4.
1.44. Okay.
Sir, I have a doubt, sir.
Tell me.
Sir, we got I1, I2 values, no, sir. And I value is 8 amperes, like the voltage one. We can substitute in the I equal to I1 plus I2 plus I3.
That also you can do.
Yeah, that is.
If you don't want to determine I3 by using the formula, if you know I1 and I2, you can determine I3. You can determine that also. You'll get the same answer. You'll get 1.44 only. 8 minus of add list, subtract list. We'll get 1.4.
Okay, sir. Thank you.
Okay. Any method you can follow. But we have to get the answer. Same answer we have to get. Whatever may be the method you are following. Any doubt? Now add I1 plus I2 plus I3, we have to get 8 ampere. Okay, next one. Hello. Okay, take the next problem. Determine the current in 3 ohms and 4 ohms. Determine the current in 3 ohms and 4 ohms using current divider. Determine the current in 3 ohms and 4 ohms using current divider. Determine the current in 3 ohms and 4 ohms using current divider. Determine the current in 3 ohms and 4 ohms using current divider. How we can proceed? Using source transformation, convert that voltage source into current source. If you have written the go to the source transformation, what you have to notebook. మీ నోట్బుక్ లో ఒకసారి వెరిఫై చేసుకోండి సోర్స్ ట్రాన్స్ఫర్మేషన్, హౌ టు కన్వర్ట్ వోల్టేజ్ సోర్స్ టు కరెంట్ సోర్స్. go to the previous pages and see.
Find
Always-
I and write the I value instead
Okay.
of voltage over there.
Okay. For voltage source, resistance will be in series. What is the resistance series here in 10 volts?
2.
2
2,
ohm.
sir.
In series with 10
2
volts. Now we convert into current source. What is the current?
5 amp.
10 ampere.
5 amp.
Arrow is upward or downward?
5.
Arrow is upward or downward?
Upwards.
Upward.
Upwards.
Because your current flows from negative to positive.
Negative to positive.
And the resistance which is in series, that will come
That
in
will become
parallel.
into parallel.
Resistance will come in parallel with this. Same resistance will come in parallel with this. Okay. Now I want the current in 3 ohms and 4 ohms. Let us take I1 and I2. Let us assume I1 and I2. Here this current therefore I1 is equal to total current. What is the opposite branch for I1?
1.33.
That is 2 into 4 by 2 plus 4. What is this value? Two into 4 by 2 plus 4, how much? 8 by 6.
1.33.
1.33, okay. That is 3 plus 1.33. This is your I1. I1 is equal to total current into opposite branch for I1 is 2 and 4 are in parallel. 2 into 4 by this value is 1.33. So 3 plus this parallel branch. 3 plus 1. Total resistance of parallel branches. Here I am writing total resistance of the parallel branches. Similarly, I2 is equal to total current into for 4 ohms opposite branches 3 and 2. What is the value of this? 6.5?
1.2.
1.2.
1.2 ohms. This is 1.2. 4 and 1.2 are parallel. I2 is flowing in 4. 4 and 1.2 are in parallel. That will be the value of I2. So in this way, we will determine the currents in 3 ohms and 4 ohms. What is I1 value?
1.53.
53.
1.53. 1.53.
1.5?
3.
3, sir.
1.53. What is I2?
1.15.
1.15.
1.153.
153.
Not audible. How much?
1.153.
1.153.
153.
1.15 ampere. Okay. This is one method. for determining I1 and I2. Now I will tell one more method using current divider rule only, how to determine I1 and I2. Okay, see here. So first I will, from negative to positive, current will flow. I is the total current. From this voltage source, from negative to positive, current will flow. Let us take I is the current flowing through this. This current will come here. Same current. Now what is the current in 2 ohms? I is the current. Okay. I is the current in 2 ohms. This current is coming here. This total current. 2 and these are series. These two are series. In series, current will be same. Whatever the current flowing from 10 volts, the I is the current flowing in 2 ohms. This I is coming here and it is dividing as I1 and I2. Draw one more circuit. Draw this circuit so that it will be clear. Draw one more circuit and indicate I1 and I2 like that. Now see here. Now current is dividing this current in these two branches. That means in parallel current will divide. What are the parallel branches now?
3 and 4.
3 and 4. See here. 3 and 4 are parallel. 3 and 4 are parallel. Suppose after converting this entire resistance into one resistance here, this resistance will come in series with this. This parallel connection will come in series with this. So if you draw one resistance here, these two will come in series. Instead of two resistances, take one resistance, this one, and draw one resistance. These two will come in series. That means 3 and 4 are in parallel. It will be in series with 2. Your total equivalent resistance of the circuit. If voltage is this side, calculate equivalent resistance from the opposite side. If voltage is this side, calculate equivalent resistance from the opposite side. From the opposite side, if you are coming 4 and 3 parallel, this parallel combination is in series with 2. That parallel combination is in series with 2. Now determine the equivalent resistance. Now I am determining the equivalent resistance of the entire circuit. I know the total voltage. I want the total resistance. I want total resistance. That is 3 into 4 by 3 plus 4 plus 2. That is 12 by 7. What is 12 by 7?
1.71.
1.7. 1.7.
1, sir.
1.
3.71. So this is the total resistance of the entire circuit. Now I want the total current. What is the total current? I is the total current. Total voltage by total resistance. Total voltage by total resistance. Tell me.
2.69.
2.67. 69.
2.67 ampere.
6,
9, sir.
2.69, sir.
9, sir.
9.
2.69.
169, sir. 69.
Let us take 2.7 ampere. Approximately 2.7 ampere. 2.69 means that is, let us round it up to 2.7. 2.7. Now here 2.7 ampere is coming into this node. This 2.7 is dividing in these two branches. Now I1 is equal to total current into, what is the opposite branch for I1?
4.
It is only 4. Only parallel branches you see. 4 by 4 plus 3. I2 is equal to total current I2 3 by this is now substitute I is 2.7. Substitute 2.7. And tell me the value.
1.5.
I1 1.54.
1.53 first one. We had to get same answer. I1 here 1.53, 1.5. Here this will be 1.153 ampere is have to get. We have to get same answers. So this is another method. So second method will be easy for you when compared to the first method. Anyone is easy if you know the procedure and formula. Okay. Let us take one more example.
So in the previous problem, the total current was 5 amperes.
Total current was in the first method.
Yes, so.
Okay, in the first method it is 5 ampere.
And I1 and I2 we got 1.5 and 1.5.
One more resistance is there. We have not calculated the current in that. That current is dividing in 3 branches.
3 branches.
Determine the current in that branch also 2 ohms. Then add all the currents I1 plus I2 and that resistance, that current also. You'll get 5 ampere.
Okay.
Is it okay?
But from the first resistance, the current will be equal now, so after passing through that resistor also.
Which one?
Amperes.
The 2 ohms you are saying? No, that is not in series, no. That resistance is not in series with 5 ampere. It is in parallel. If you take at the node point, that current will be dividing in those 3 branches. So we have to add I1 plus I2 plus current in 2 ohms. That will give 5 ampere. Is it okay? Now see in the second method, if you add I1 and I2, you have to get I there. See the second method. Add I1 plus I2, we will get I value there in the second method. What is I in the second method?
2.7.
2.7, sir. 7.
2.7. Add I1 and I2, you have to get that value, 2 point something. Are you getting?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So if you in the first method also add the current in all the 3 resistances, then only you'll get 5 ampere. Otherwise you won't get. Okay.
Yes, sir.
See here. Determine the current in all branches using current divider rule. Determine the current in all branches, in all resistors, sorry. Determine the current in all resistors using current divider rule. Determine the current in all resistors using current divider rule. Okay. See here. Now I write down from negative to positive current is flowing. From negative to I is the current flowing in 1 volt. So I is the current flowing in 1 volt because 10 and 1 are in series. In series current will be same. Now this I is dividing here at this node point. Now this current I is dividing at this node point. Let us take this is I1, this is I2. Let us take this is I1 and this is I2. Now again this I2 is coming at this node point. Again this I2. Let us take this is I1 and I2. I1 is flowing in 3 ohms, I2 is flowing in 2 ohms. Again this I2 is coming at this node and it is dividing as I3 and I4. I3 is the current in 4. I4 is the current in 5 ohms. Like this current will divide. Only at node point current will divide. See at this node this total current is dividing as I1 and I2. Here I is equal to I1 plus I2. Now this I2 is coming here. This I2 is dividing as I3 and I4. Therefore, I2 is equal to I3 plus I4. If you add I3 and I4, you have to get I2 because incoming current is equal to leaving current. Here also incoming current is equal to leaving current. Now I have to determine. First, I want to determine the total time. Total current is equal to total voltage by total equivalent resistance. Total voltage is 10. Now I have to determine equivalent resistance. If voltage is this side, calculate equivalent resistance from the opposite side. Calculate equivalent resistance from the opposite side. Now see here, current is dividing in these two. That means 5 and 4 are in 5 and 4 are in parallel. If current divides, then those branches will be in parallel. Where current is dividing in these two. If you combine these two as single resistance, if you place one resistance here, this resistance will be in series with 2. This parallel combination is in series with 2. That parallel resistances are in series with 2. Now see here, I1 and I2. Now let us take this as one branch. Let us take this as one branch. Now here if you keep one resistance here, these two will be parallel. See here current is dividing as I1 and I2. That means this entire branch. Now let us take this is one branch. These two parallel in series. Now this entire branch is in parallel with this entire branch is in parallel with 3. Now this entire branch is in parallel with 3. Now keep one resistance here. This entire connection will be in series with 1. This entire thing is in, now see how we have written parallel series. Parallel series. See first these two are parallel. Then series with 2. Then parallel with 3. Then series with 1. This is your equivalent resistance, R equivalent. This is your equivalent resistance, total resistance of the entire circuit. Now we will calculate the entire resistance. 5 into 4 by 5 plus 4.
2.4. 2.4.
How much?
2.4.
20 by 9, how much? 1 point? Sorry.
2.2, sir. 2.2.
2.22, okay.
2.
We have calculated only this. See here, first we are calculating this, then we will add this. 2.22 plus 2, that is 4.22. In parallel with 3. So first we calculate this bracket, then this, then parallel with 3. Parallel with 3 means R1 R2 by R1 plus R2. This is R1. R1 R2 by R1 plus R2 plus 1.
1.7.
0.7 plus 1.
1.7.
2.75.
2.75.
2.75. sir.
Okay.
Total answer is 2.7.
2.75 ohms. Actually, this is 1.75 plus 1. That is 2.75 ohms. 2.75 ohms. So we have calculated the total current now. I is equal to total voltage by total resistance.
3.6.
3.3.
3.6.
3.63.
3.63. Okay. Now we got current in 1 ohm. What is the current in 1 ohm now? 3.63.
3.
So this is the current in 1 ohm. 3.63 is the current in 1 ohm. Now this 3.63 is dividing in these two branches. First let us take I1. I1 is equal to, what is the total current? Total current into, what is the opposite branch for 3 ohms?
4.2.
4.22.
4.2.
For this 3 ohm, this is the opposite branch. See 3 ohms, opposite branches 5 and 4 are in parallel, in series with 2. The value of this is, for 3 ohms, opposite branch is this one, 4.22. 4.22. Now take this as one resistance, this entire thing as one resistance. For 3 ohms, opposite branch is this one, inside this square brackets. 4.22. This entire value is 4.22. What are the parallel branches? 3 and this are parallel branches. Total resistance of parallel branches. Now I is 3.63 into 4.22 by 7.2. This is I1.
Two point one two.
2.12.
2.12. Total current is 3.63. What is the opposite branch for 4.2? I2 is flowing in this entire branch. See, I2 is equal to I3 plus I4. That means this entire branch. Opposite branch for 4.22 is, what is the value? 3 and 4.22 are parallel. I2 is flowing in 4.2. That means 3 by 4.22 plus 3. So I2 is flowing in 4.2. This entire branch. Your I1 is flowing only in 3 ohms. I2 is flowing in 4.2. This entire branch. So this entire branch 4.2. For this opposite I2 opposite branch is 3. The opposite branch resistance by total resistance of parallel branches.
5.58.
1.5.
5.5?
8.
No.
1.5.
1.50, sir.
1.50. 50.
50.
1.51, sir.
1.508.
Okay, let us take 1.51. Add this I1 and I2. We had to get 3.63. If you add I1 and I2, we had to get I2. I is equal to I1 plus I2. If you add I1 and I2, we had to get I2.
Yes, the same value.
3.63 ampere we had to get. Okay. Now we will go for I3 and I4. For I3 and I4, what is the total current? What is the total current for I3 and I4 branches?
I2 1.5.
I2 is the
1.5.
Therefore, I3 and
1.5.
I4 total current is I2. For I3 and I4 total current is I2. I2 into, what is the opposite branch for I3?
5.
5.
5.
5, sir.
5 by 5 plus 4. Parallel branch. Now we know I2. 1.51. Substitute here, we'll get I3 and I4.
Zero point 8.
0.83.
0.83.
Okay. This will be
0.7.
Same, sir.
Same, sir.
Same, sir.
Same, sir.
are you getting same value?
Yes, sir.
No.
Same value.
Yes, sir.
Some difference will be.
I2
So both
into
are same, no, sir.
Sorry.
Sir,
Here,
opposite branch is
branch
4,
is
no,
I2.
sir. There, yes.
Is 4.
4.
Is 4 here. Opposite branch for I3 is 5 ohms. Opposite branch for I4 is 4 ohms. Sorry.
Zero
0.66.
0.67.
67.
Now add these two, we have to get I2. I2 is equal to I3 plus I4. We have to get 1.51. If you add these two, we have to get I2.
Yes, sir.
Yes, sir.
Okay. In this way, by using current divider, we can determine the current in any branch. Okay. Okay, wait for some time, I will take the attendance.